Hey everyone, glad to join everyone virtually. Good afternoon, good evening. Um, I will share my screen. Hopefully everyone can see this. Again, thanks so much for having me. There's a couple of folks running around with Big N Nets t-shirts on. So if you have any questions towards the end, there we go. Um, Feel free to ask them some questions and happy to hear from everyone. So Nate from Splunk was just talking about the flow of information. And my name is Derek Collison, and I've spent the better part of my career working on the flow of information, the intelligent flow of information. And so the talk that I wanted to give was around rethinking connectivity. And what's interesting is that I think folks probably are aware that we've undergone massive transformations in connectivity as humans from the early 93 94 of the internet to the global cellular network to essentially after we've been in a pandemic for 18 months or so, a profound sense of hyper connectivity. Unfortunately, the systems that we are depending on, the systems underneath the covers that we're actually dealing with, um, kind of look like this. And this is a problem because I really do. We've flowed from the data economy to a connective economy. And I think that is incredibly important to understand. And if this doesn't necessarily resonate, there's a couple things that we can point to that kind of highlight this in a really big way. Our own biological, brain, right? In terms of the most important thing, and that thing is the way things are connected. If you looked at data centers back when I started in the 80s, you cared deeply about the computers and the disk drives and the spinning, rust and the lights that were blinking. If you go into any modern data center today, all you see is wires and cables and things. The importance cannot be understated of how powerful this transformation can be. If we look at where we are today with baseline and of course Web 3.0 talk and IPFS and of course going back to even e-commerce and such like that, this is actually from a ecological standpoint a very short period of time that we actually got all of this kind of to come to fruition in the last probably 30 years or so. I believe the real value in innovation is enabling the secure and hyperconnected world, right? The intelligent flow of this information. And I really do believe we're in the middle of a massive, massive transformation that because of all the world events that are going on, it might be hard to really see what's going on. But I can promise you it's going to be radically different 10 years from now than it was probably 50 years ago. It's accelerating at an exponential rate. So some of the limits of today's technology, why the lady plugging in the switchboard do I think is so applicable? Well, if you actually kind of peel that onion and look, everything's still based on addressing the discovery of DNS and host names and IPs, right? And even though we've tried to paper patch around a lot of these limitations, it's still the fact that you have to kind of figure out who I'm trying to call, what phone number they might be at, whether it would be a desk phone, wall phone from the 70s and 80s. And even before that, maybe calling the person, in this slide to connect us, right? Everything's an implied point-to-point conversation. It's a one-to-one conversation. Through the pandemic, how many people have been on Zoom calls that are only one-to-one? They happen for sure, but most of them are a group setting, right? It's this M-to-N type stuff. Everything is pull-based. I ask a question and I get an answer. But obviously, there's push-based patterns that make a lot of sense, especially in this new world order that we're about to go into. There's the notion of front end and back end personas. They're different, right? The front ends can maybe run on a web browser or run on your phone. The back end should be running in a cloud behind a firewall and behind a load balancer and a VPN and things like that. And HTTP is not our future. It was an amazing technology that got us this far, but it should not be the state of the art on how the technologies and how digital system service and devices actually communicate. So a possible solution, right, around rethinking connectivity is, well, what happens if we had totally location independent addressing? Doesn't matter I don't know where any of you are. You probably don't know necessarily where I am. We don't know the physical substrate that the electrons are going over, right, to broadcast this video, whether it's satellite or cell or fiber or wireless or Wi-Fi. End-to-end communications, meaning never really understand who could potentially be an audience member for any type of communication. That's very, very hard, and we were actually kind of have these implicit biases that we might not be totally aware of. Push and pull based, right? I don't want to keep polling for things. I want things to come to me and allow me to keep synchronizing the things that I might care about. And it might not be me as a human. It might be me as a digital system, service, or device. Secure by default. Again, not sure the age of the audience per se, but I remember, when we didn't even have a green lock on the internet, right? So you couldn't do banking, you couldn't do e-commerce. Amazon as a Goliath in e-commerce couldn't have even existed. So this new world order, it has to be secure by default. We can't wait 10 to 15 years to actually figure out the green lock here. And you can do things patterns wise, like microservices, streaming. You can do any pattern you want. You don't have to keep picking and choosing different technologies based on different patterns that you actually might want to enact. Decentralized by default, I think that's kind of a big theme of a lot of the folks, both in the audience and online, looking at this around what does it actually look like. And I really do believe we're at the very, very beginning of again, massive transformation from centralized architectures, centralized entities, whether they be countries or governments or very large technology companies, to a very peer-to-peer type of collective. And we'll talk about that in a second. And then this notion of intelligent persistence, which we'll talk about in a second. So Synadia uses a technology called Nats.io. Nats is an open source CNCF project that I created about 10 years ago or so to power a project that I was working on at VMware called Cloud Foundry, which was kind of a platform as a service. It's a modern connected technology that ticks all of those boxes that we were looking at. Location independence, no implied one-to-one communication, secure by default. And again, it has that intelligent persistence layer that we will highlight in a second. It's a family of open source clients. We have about 46 now, I think, client implementations, and a server that's written in Go. Again, rock solid, been around for about 10 years, that is lightweight enough that you can run it on a Raspberry Pi Zero if you wanted to. And so these things are not like your father's message broker or something maybe like Kafka, big and heavyweight, but think of them as very lightweight, very easy to Lego brick together to form global meshes that can transcend any cloud, any edge, any geo, things like that. And so NATs can actually power these decentralized peer-to-peer systems, streaming systems, microservices, intelligent persistence, and this wave of intelligent adaptive edge, which we're at Synadia are seeing quite a bit of activity around, taking on not only IoT or Industry 4.0, but this notion of collective intelligence using physical substrates like 5G and Starlink and things like that. This collective intelligence is really important to me. I believe that this massive wave of propagation around machine learning and artificial intelligence to get interactions with systems to be more and more intelligent need more and more information, intelligent data, so to speak. And a lot of the companies that we associate with pushing the envelope around machine learning and artificial intelligence are very, very large. So they have a lot of gap to keep going, to keep improving the experience for their customers without ever having to go kind of outside of their own ecosystem. But I can promise you that's going to end very quickly, meaning that a technology like this needs to be more like Switzerland. It can't be necessarily owned and dictated by any given large company. You're going to have to start, sharing. For example, Nate was talking about that around an insurance claim, I think, just in the last talk. But you can imagine even smart cities, right? They're immediately in a collective intelligence situation. And that means that this type of a system, again, the connectivity layer, so to speak, in the intelligent persistence, it also cannot be owned and operated only by a single company or organization. And so we've strived very hard from an open source ecosystem perspective to make the servers, very, very powerful and useful as a single server. But then you can cluster them together. Then you can cluster clusters of clusters together. And we'll talk about security in a second, but all of this with a zero trust, secure relationship between different providers or different enablers. And very importantly is what we call a leaf node. And don't concentrate on the leaf node. I'm very bad at naming things. But what a leaf node says is that you can actually join a system and run your own servers. So you can actually extend a utility. So if I think about it, if you can generate your own electricity, or the example that I give quite a bit is I could buy my own cell tower and stick in my backyard for when I'm at the house. That is very, very possible with NATS technology. Matter of fact, it's by design, because we don't believe that whatever we contemplate and think of and build and deploy will ever meet the needs of what, again, we're about to go into in terms of this radically different ecosystem. Jetstream is our persistence layer, but it's not just the notion of persisting messages, right? Which is what NATS is throwing around. And people can get very tied up in the fact that, oh, NATS is just sending messages. What can we really do with this? But obviously, the video feeds that the people are seeing, both in the audience and online, are being delivered through multiple substrates, through Ethernet packets, cellular, whatever that is. And so the notion that NATS at its core is a pub sub messaging type of a system actually quickly abstracts out away. And so with Jetstream, we can store messages, obviously, but we can horizontally scale that, right? So we can select your desired replication, your disaster recovery strategy. It's secure and reliable, meaning both data at rest and in motion are encrypted, and data is strongly hashed and checked every time it's loaded back off of disk and moved around. Again, that intelligent flow, so to speak. The notion of intelligent digital twins. Can I capture the state of something and then replicate it somewhere else in a digital form, and actually interact with that in a meaningful way? And can that not just be one? Can it be as many as I possibly want, right? And Jetstream has the notion of both one-to-one mirrors, meaning I have a stream of messages that I want to mirror over here, or I can say I want to collect all of the messages and the streams of messages from every remote being a plant, factory, store, distribution center, oil rig, airplane, car, it doesn't matter. Cube satellite we've done. And we can actually mux them into a single stream, right? That actually represents all of those remote endpoints. And very importantly, again, because of the fact that Jetstream is meant to be an extremely useful and general tool, is the concept of materialized views. And what I mean by that is of course, we can store a single message, and things like MQTT, which we can natively connect to, they care deeply about that. But we can also store a globally ordered set of messages. No matter where you access this from, anywhere in the world, the order is maintained. It's exactly the same. And building upon those two simple constructs, we can start to do incredibly powerful things with a single technology, which is we can abstract out key value stores over this, secret stores with real-time updates where, again, with the power of NATS, I can say, I want to be very interested in this subset of this key value store, and I want to be updated anytime anything changes. Don't make me keep asking and polling. Actually push the updates to me in real time. And of course, we can also do object store, right? You can take anything that you want per se and chop it up into a bunch of little messages. And guess what? We've actually abstracted that out as well. The key part on the globally ordered set of messages that's not to be missed also is that the fact that we can do this means that we can replicate any state machine anywhere securely and reliably and one-to-end. In other words, it doesn't have to just be one-to-one. So you can, replicate databases. You can replicate all kinds of things with a simple technology like this. NGS is our version of a global utility that's based off of NATS. We believe very strongly that this new world that we're going into, this very peer-to-peer decentralized world, is going to be run off of things that are utilities, not silo tech where I buy a copy, you buy a copy, and those two copies never will talk to each other, which is, a lot of enterprises and things do that. But NATS was purposely built to run a global utility that, again, because of the leaf nodes, can be extended. In other words, you're never blocked by what NGS is today. You can actually set up your own server, your own clusters of servers that interact at a very, very fast rate for yourself. But obviously, because of the intelligent routing, when you need things that are on the larger global utility, the messages just flow there intelligently and securely. We can do things like microservices and streaming and persistence and materialized views from anywhere and anything in the world, telephone poles, microcontrollers. And essentially, we give you the equivalent of like a SIM card. We call them the credential files, which uses public and private key cryptography to get access. So you don't need VPNs and firewalls and load balancers and all that kind of stuff. It really is kind of I'm dating myself here, but a digital dial tone, right, for the modern world. Now, baseline and NGS, this is where things become pretty interesting as well. When we look at baseline and we look at this peer-to-peer decentralized system, Kyle and John were kind enough to reach out to us and say, hey, we think there is a potential here, right? There's going to be a level of sophistication around communications and connectivity that we haven't seen before. And HTTP, is probably not going to be it, So things that are starting to feel very peer-to-peer and decentralized, but are based on this construct like IPFS, they might have to cede to something that presents exactly what IPFS is trying to do, meaning the data that I want is anywhere that I want it to be intelligently. But I would imagine at the end of the day, it will not be based on point-to-point communications and things like HTTP. So specifically the baseline, though, right? We've got, decentralized authorization and permissioning, and we're starting to work very closely with Kyle and Provide and John and the larger community, and we're excited to be more involved as we go forward. High-level controls of ingress and egress, streamable, replayable, new participants easily can be added, globally fault tolerant. I call it xCloud, xEdge, xGeo, anywhere, anytime, anything. And also in terms of the lower OpEx, right? This Provide stack is the reference implementation for baseline. It's an OASIS standard that's been the Provide implementation. I apologize, that shouldn't say lower OpEx, it should say Provide. That's my fault. But the OASIS standard, which I think John says was ratified, which is awesome. And Provide is actually using NATs and connectivity to NGS as its core architecture. And Kyle and I have been going back and forth collectively since 2017, both with a shared sense of this vision of what's about to happen in terms of technology and the world that we live in. And so we're super excited. I really think that it is a great time to look at neutral open source technologies that can really revolutionize the way we connect things. And it doesn't mean that we're going to change the way we communicate, right? So I'm on Zoom, I'm going through a video, but even in the 80s, if I gave you a call on your wall phone or desk phone, the conversation would still be kind of similar. But we couldn't imagine going back to that world, right? And I believe that technologies like NATs, maybe something else that actually kind of drag in this notion of the internet, and then the notion of the secure internet, the global cellular network, and then of course the operators actually allowing you to switch operators and roam intelligently with decent speeds, right? That now feels natural to us, and we wouldn't want to go backwards. And I think the same thing's about to happen with kind of the future of the way digital system, service, and devices connect and communicate and make our lives a lot better. Here's some of the enterprises that are leveraging NATs. There's probably a larger group, but folks that are looking at NATs are kind of like, I've never heard of it. I don't know about it. You're in a good set of company. Like I said, it's over 10 years old now. The Jetstream technology is about a year and a half old with the intelligent persistence, but we've already got people in production. Matter of fact, some of the folks that are on this slide here. And we're super excited about where things are going. We think that, this is just the beginning, as a couple of the other speakers have said. If you're interested in some more information, the big ends should be, there's a couple of folks there, Brian and Steve. Please grab them, ask them any questions. And then there's some more information here if you want to find some things out. But thank you. I really appreciate the time. And connect your world.